Once we've cast off, we will be relying on navigation to tell us where we are and to chart a course to our next destination. Hi, I'm Ray Ashley and I'm Star of India's navigator. We're going to be using 3 phases of navigation today. We're going to be using piloting to get us out of the harbor, coastwise navigation when we're offshore, and celestial navigation when we're out of sight of land. Inshore, we'll use piloting to navigate channels and to avoid shallow water. We may use a sounding lead, like this, attached to a lead line to tell us how deep the water is or to pull up a sample from the bottom. Is it sand, mud, or rocks? Because he knows our harbor best, our pilot helps our captain and others to navigate in and out of port and to supervise our tow out. While aids to navigation help to mark channels and obstructions, piloting must also take into account tides and currents, other traffic, and hidden shoals. At night or in a fog, lights or sound signals may be all we have to keep us off the rocks. As we clear the harbor and set sail, the last channel markers say goodbye, and they will be the first to welcome us back. With his job finished, our pilot will leave the ship by way of the Jacob's Ladder, and we will drop our tow. On our own now, we will rely on coastal navigation, using features ashore to tell us where we are. We know we're here at Buoy 1, so I lay out a course which should take us clear of Point La Jolla. We make that course out to be, using the compass rose, about 334 degrees. Our helmsman steers 334 degrees, and the crew adjusts the sails to this course. We can guess our position, but the ship's leeway and currents may be setting us off course and bringing us too close to shore. So, to make sure of our position, I will take bearings on charted landmarks, such as the Point Loma Lighthouse and the SeaWorld Tower. Okay, Point Loma is bearing 112 degrees magnetic.
SeaWorld Tower?
SeaWorld Tower is 055 degrees magnetic. Next, I plot the 112 degree bearing on Point Loma using the compass rose and the 55 degree bearing on SeaWorld. Our fix tells us that our position is here instead of where our deduced reckoning position has us, here. And if we continued on this course, it would take us into the beach. So instead, we plot another safer course which takes us further out to sea. However, once we sail offshore out of sight of land, I'll not be able to fix our position by using features on the coast. Instead, I will have to use celestial navigation, with the sun, the moon, and stars being my only fixed points of reference. The sun is perhaps the most important celestial body that we use for navigation. It appears to migrate between the northern tropic and the southern tropic in the course of the Earth's annual orbit. But from the surface of the Earth, it will appear as though the sun rises in the east, comes to a point overhead, and begins to set in the west. But if we capture it at that moment, where it's the highest point in the sky, and measure the angle between the sun and the horizon at that moment, that angle will tell us the distance we are north or south of the equator at that moment, and therefore our latitude. Our position at sea is defined by a grid or coordinate system composed of lines of longitude, which tell us how far east or how far west we are of the prime meridian, which runs through Greenwich, England, and lines of latitude, which tell us how far north or south we are of the equator. Lines of longitude all run together at the poles, while lines of latitude are all parallel to the equator. For centuries, latitude north or south and longitude east or west have been used as coordinates to locate one's position at sea. Mariners have known that latitude can be found by subtracting the sun's angle at noon from 90 degrees. The sun's angle was found by sighting the horizon and the sun with instruments such as the crossstaff, or by using the astrolabe, which hangs perpendicularly the angle between the sun and vertical. Unfortunately, these devices could cause blindness from staring too long at the sun. The sextant solves this problem by using filters and mirrors to safely bring down the sun to the horizon, thus measuring its angle. At about noon, I take a series of readings. The highest one will be when the sun is exactly at its zenith.
Mark.
Okay. 48 degrees, 48.5 minutes. Our highest reading is 48 degrees, 58.0 minutes. Dropping the minutes for purposes of simplification, we'll use only the 48 degrees to calculate our latitude. The formula for our latitude during this time of the year when the sun is in the southern hemisphere is our latitude equals 90 degrees minus our sextant angle minus the sun's declination. So that 90 degrees minus the reading we got from the sextant, 48 degrees, gives us 42 degrees. And the sun's declination, which we got from the Nautical Almanac, was 8 degrees south. When we subtract that, that gives us north 34 degrees, which is our latitude. So we know we're somewhere on this line of latitude, 34 degrees north. So that running down a latitude due west simply means steering a course of 270 degrees true. Columbus sailed to the latitude of where he expected to find Asia and continued on across until reaching North America. Of course, Columbus never dreamed how far he would have actually had to sail had North America not been in the way.
It's come to course 270.
270 it is.
We're sailing due west, 270 degrees on latitude 34 degrees north. But where are we? We will use dead reckoning to estimate how far we have come since our last known position. How long has it been, and how fast have we been sailing? Be aware that speed through the water may not be the same as that over the ground.
Let's give it a whirl.
The old chip log paid out a line with knots in it.
Stop.
1, 2, 3, 4.
A number of knots in a set period of time could be used to calculate speed through the water. The taffrail log deploys a spinning line which allows us to read distance directly in nautical miles, much like an automobile odometer. We've sailed at a speed of 6 knots, or 6 nautical miles per hour, for the last 24 hours, which means we've sailed about 144 miles. If we come over to the chart, 1 minute of latitude equals 1 nautical mile. So, if we measure 72 nautical miles on this scale, and then come over to our position of noon yesterday, and come out 72, 144 miles due west on a latitude of 34 degrees north, this is our position 24 hours later. We should be here on our course, but then again we may not be, depending upon leeway, current, and other factors. Maybe that's why it's called dead reckoning. We can be much more certain of our position by taking celestial sights at dawn or at dusk. Because the position of any celestial body is known for each moment, we can use the sun, the moon, the planets, or a star at the moment of observation to become a fixed point, the same way that we use buoys, lighthouses, and other navigational aids. The chronometer measures absolute time with precise accuracy, and that allows us to pinpoint the exact moment that we make an observation of a celestial body. Once we have that information, we can use astronomical tables like those in the Nautical Almanac to determine the precise position in the sky occupied by the celestial body at the moment of observation. We can then take that angle combined with the position of the celestial body to determine our own position on the surface of the Earth. Taking the information from the sextant and the chronometer, we are able to perform a series of calculations that put us on a line of position relative to each celestial body, just like when we shot the Point Loma light in the SeaWorld Tower. Our position is where these lines cross. Note how far we are from our dead reckoning guesstimate, about 15 miles. Well, we can sail where the winds take us, all the way across the ocean, with nothing to guide us but the compass, the sun, the moon, and the stars. We can tack or change course as we need to, without needing to follow a line of latitude or relying exclusively on dead reckoning guesstimates. Whether far at sea, cruising coastal waters, or piloting inshore, we know where we are going, and how to get there safely. And that is what navigation is all about.